Good afternoon, everybody. I am Karthikeyan from CII Godrej Green Business Center, India. It's my pleasure and privilege to introduce the Swedish Energy Agency and the speakers from Sweden to Indian participants. Before introducing the Swedish Energy Agency and Indian participants, my friends, with the support of Swedish Energy Agency, we have initiated a new activity called Innovation Acceleration. The main objective is to identify innovative technologies from Sweden and to facilitate the business development of those innovative technologies in India. And Mr. Ludwig and I have been working on this for quite some time. The brain behind or the entire concept was conceptualized by Mr. Ludwig. CII is anchoring this from the Indian point of view, and we are also taking the support from Business Sweden. Mr. Sandeep has been coordinating in this regard. The idea is the Swedish Energy Agency will identify the innovative technologies which are very well proven in terms of technical aspects and also commercialized in Sweden and other areas. And we will introduce those technologies in India and see how those technologies could be taken up further for cleaner production and sustainability aspects in our country. So today we are planning to have two presentations, one from Mr. Fredrik Johansson of FOV Biogas and the next one from Mr. Peter Vasiliev of NeoZeo. So the webinar structure, if you look at, there will be a presentation from these two speakers, and then you can pose the questions through the typing. So the two-way communication is quite difficult in this webinar sector. So my request is, I would request you to type the questions. The question, what we will try to do is all the questions can be compiled and then answered at the end of the presentation. So now may I request Mr. Ludwig to introduce the Innovation Accelerator Program and to the audience and hand over to the respective speakers, please. Over to you, Mr. Ludwig.
Thank you, Mr. Karthikeyan. As Mr. Karthikeyan said, this program is a joint program between CII, India, and the Swedish Energy Agency, and also government offices and Business Sweden from Sweden. And the purpose is to facilitate collaborations between Swedish and Indian actors in the area of energy. The actors could be innovators, interested of entrepreneurships, business, academia, and so on. When it comes to the selection of the Swedish actors, we are not targeting any specific technology area. The criteria is the relevance for the Indian context. And we also look for companies and actors with an expressed and dedicated interest to work in India with Indian actors. The companies should have cutting-edge solutions in the area where they are active. So we're not really approaching micro or SME, but both micro and SME companies. And it's open for any companies in Sweden that has that are front runners in their specific area. And on the Indian side, we hope to approach similar actors with an interest to interact and develop with the Swedish actors and develop solutions for the Indian context. The reason why the Energy Agency is engaging in this is that it's part of our mission. We are a government authority responsible for development of a sustainable energy system. That includes, of course, a lot of international collaborations. One of our main tasks is that we're the largest funder of R&D in the energy area. The consequence of that is that we're also working with commercialization of the R&D results. And as many of the Swedish innovations and inventions have their greatest potential in other contexts and markets than Sweden, it also has to be part of our international collaboration. And here it's part of our collaboration with India. And so now I would like to introduce Mr. Fredrik Johansson from the biogas company FOV Biogas. They have a very interesting technology that we see is relevant for the Indian context. It's a very cost-effective solution for production of biogas, raw gas. So with that, I hand over to Fredrik Johansson to describe a little bit more in detail about the technology and what they're looking for in India. Thank you and welcome.
Well, thank you very much, Ludwig, for the kind introduction. Could someone, do you see my screen? Could someone tell me that that is what you're seeing? That would be good.
Yeah, we saw your screen.
So FOV, very good, thank you. So FOV Biogas, we are a global supplier of biogas systems. I've chosen a picture here because in this picture you can see myself. I'm the blonde guy in the middle. And then on my left in this picture is Professor Mohammad Taherzadeh, who is working at the University of Borås, and we are actually the two innovators of FOV Biogas, and it is Professor Mohammed's assistance in this that has made it possible for us to develop a biogas system made out of a textile material, which I will tell you a little bit more about. Our mission is to make biogas technology an accessible and reliable investment for as many people and organizations as possible. The way we're doing this is by giving a complete solution to your waste and energy problems. We make our reactors out of high-tech textile materials and sophisticated polymers. We are also very focused on having a cost-effective solution so that your investment becomes a good investment with a short payback time and a good return on investment. And we also like to provide you with a first-class service and support, because once it's been installed it also needs to run, and it should run and run forever and without any problems. And in order to enable that you need some local support, and that is built into our concept. One other thing that comes with our package is that we are together with the University of Borås also running a global R&D. And I'll talk more about that later on in my presentation. Here you can see one of our bigger reactors. It's me in the picture. We have three categories, we can say, of products. We have these what we call these bigger reactors that goes from 500 cubic meter and upwards to a couple of thousand cubic meter. Then we have the mid-size that are somewhere from 20 to 500 cubic meter, and then we have very small ones from 2 to 50 cubic meter, mainly for households, that you can see in this picture. Our system or our concept is based on four fundamentals. One is to provide the highest quality, a quality that is reliable, that will continuously make you produce biogas. And this is then supported by local support, what we call this superior support. We also have a unique scalability which enables you to test things and then scale it up in a very easy way. And combining all of these three factors will give you a very cost-effective solution at the end of the day. At the bottom of this slide there is an animation, and I will not show this time. You can find that on our website. It's a film which shows fairly well what it is that we do and how we do things. Highest quality, what is it that we mean by this? As I've said before, we have developed a very special textile material for the purpose of producing biogas, and this gives us, in comparison to traditional systems, some benefits. The material in itself is very lightweight and flexible. At the same time, it's also very durable and also very strong. That enables us to build very large systems. And because it's made out of a textile material, we can customize it even though we are using industrial processes with industrial quality and industrial standards. And this, of course, then makes it possible for us to have different sizes and to assist in easy scale-ups. And also, which is always maybe most important to us, it needs to be very cost-effective. It needs to be a good investment for the customer. Here is some pictures from our production. The top left one is from where we do the welding of the material. The top right one is the testing procedure where we make sure that there are no leakages and that everything is correct before we ship it. Bottom left is mainly how we weld it together, and also in the fourth picture there is we continuously do field test and prototype testing of everything that we do. This is the way it arrives, our system, and this package in particular is a 100 cubic meter reactor. As you can see, it's foldable and it's also very lightweight. This one weighs, I think, roughly 75 kilos, and this in turn makes it very easy to distribute, easy to store, and it's easy to take back, and you can actually resell it. And why we put that in is that makes it also possible to get it funded by banks, because it's an asset that you can take back. So it is possible in that way that if it doesn't work, or if it's not to the purpose, or if it's not being paid for, then it can always be taken back, and that is a big advantage actually. Here you can see a picture of where it's been unfolded, and this is before we start filling it up. And what this material that it's made of gives us these advantages over traditional systems, that it is very strong, lightweight, foldable and flexible, and yet it's highly resistant to high temperatures. Its resistance to the chemical or the biogas atmospheric conditions that it's been in, it's highly UV resistant. So that is the material. Then regarding our superior support package, wherever we establish ourselves in each and every market, we try to do this through universities, through research institutes, and through local distributors and sales agents that we train, and also together with the research institutes and the universities, we start to do local research. And that means that we can assist you with business cases, installations, we can optimize the process, we can help with maintenance, and we can help to scale up. Also included in this investment is this, that we are local. So that means that we're not that far away. We can come to your place very quickly, and we can help you very quickly. We are not this far away person, which is very expensive maybe, that needs to travel a long distance before they arrive. That's not the case. We will also train your own personnel, and we will give you all kind of assistance that is needed in order to have a stable and reliable biogas production. We have, as we are in many places, we are in South America, Africa, and Southeast Asia. We have, of course, seen a lot of different biogas installations and biogas systems, and in most of the cases where it doesn't work, it's mainly due to lack of support and lack of maybe competence, and this is then the way we try to overcome this problem. Superior support, as I said, producing biogas is on the one hand, it's not that difficult, but it can be quite tricky. There are a number of parameters that goes in, and that you need to have a good understanding of, and how that how it all works together. And this slide here is just mentioning a number of these areas, which is important that you're in control of. And I think most of our customers, they are not biogas producer experts. That's not their core business. So maybe it's a little bit too much to ask them to have a knowledge about all of these things. But this is, we have that, and we can then support and help you, so you will have your reliable production of biogas all times. Here is a picture of roughly, or a schematic picture of how a system works. You have the organic waste that goes in, and you have a mixing tank where you prepare your substrate before it goes into the reactor. Then it goes into the reactor, where it stays anything from 20 to 50 days, all depending on substrate temperatures and different conditions. Out of this, you get your biogas, and which can then be used directly as it is for heating, cooking, gas lighting, or maybe even retail, that it's been sold, or it can be converted into electricity, or used for fuel cells, or compressed biogas for vehicle fuel, where you need more extra equipment in order to do this. And then on the right you have the outlet, that after the 30 days it comes out, and then there are different things that can be done with it, but the use of it is mainly that you use it as fertilizer, either yourself or you sell it to someone else who needs it. The unique scalability concept is that this enables a number of different things. You can start very small in order to reduce risk. Maybe you're a little bit uncertain of what biogas is, whether it will work in your organization or not, and will it actually produce, will your substrate or your organic waste, will that really work? If there is a big uncertainty, then there is no need to do a full-scale implementation, which is traditionally the way you do it for cost reasons. But we can offer maybe or perhaps a 3 to 6 months demonstration where we can prove these concepts. And after this, if you're satisfied, we can go to full implementation. and we can do it at a pace where we can do it step by step, so we don't need to do it all in once. We could just connect one more reactor or replace one, and this is done very easily and very quickly. I've said it several times. When it comes to the installation of it, it's done very quickly. There is a bit of preparation for a bit of ground preparation that is needed. Then we install the systems in a day or a couple of days time, depending on maybe the complexity of just depending on the specific situation. But anything from a day to a week's time, that is normally the time for installing it. A typical demonstration installation that we can offer is quite often it's a 100 cubic meter reactor. The time needed in order to do the evaluation, also depending on the situation a little bit, what it can be used for inoculum, for instance. So it depends on how quickly you can get the biogas process going. But 3 to 6 months, you get a very good understanding of it. We then do a thorough evaluation, and you can have an informed full-scale implementation. By this we mean that it is your conditions, it is your substrate, it is your situation that is being analyzed, and it's that data that goes into the full implementation calculation. So it's most of the risks are taken out. And this is totally unique in the industry. This cannot be offered by anyone else or any other technology than ours. Reliable investments for reactors. I mentioned the different sizes. Installation is 1 day to a couple of days. Lifetime of the reactors is more than 10 years. Payback time should be less than 5 years, all depending on different market conditions and situations, also for the customer themselves, how they want to progress and for what they want to use the biogas that's being produced. But it should be lower than 5 years. Typical is roughly 1 to 2 years time. Maybe in some cases we have 3, but that's normally 1 to 2 years time is the payback time. Summarizing this cost effectiveness is sort of a reliable production which is based on highest quality and superior support, lifetime of well over 10 years. And you can do your investments gradually. That we see as a major advantage, at least if there is very little experience in the field of biogas and if the uncertainty is big with the customer. Customers and different waste types to the ones that we are supplying this for. Agriculture is of course one sector which is big. Industries is another one. Marketplace, fruit markets, meat markets, and so forth is a third one. Eateries, with that we mean restaurants, cafes, food courts, canteens, hawker centers. In all honesty, there the main area has been canteens. Canteens and also household is the main that has been. We haven't done any for restaurants yet. Housing, there we have different things. Campuses, different university is one, for instance. Public toilets is also an area where we have done tests. And then, of course, governments. We want to work on national and regional distribution programs, both for small reactors, which is typically the most common one, where there are different national programs on implementation for household reactors for household and small farms. But also we are interested in and working together with municipalities to handle their organic waste and wastewater treatment, of course. Next slide is some customer and waste hubs that we've been handling. There is this slaughter house in the top left corner, and then we have dairy cows, fishing industries, we have pig farms. In the middle it's palm oil, which we're doing in Indonesia. To the right, that's tobacco, that's Vietnam. Left is wastewater. All the bottom ones are different wastewater from different industries. So that's also typically, I think that the left one is from this fishing industry, the middle one is the tobacco, and the right one is from a rubber industry. One other interesting one is leather tannery is we're currently doing in Indonesia, for instance. Also, a little bit special is the smallest product that we sell is the household reactor, and then we have it do-it-yourself kit. I just chosen to show a slide on that. There is more information on that in particular on our website. Here is a business case where you can see it's less than a 2-year payback time on this. This is a typical digester of 3 cubic meter for a household. Producing 1 to 2 cubic meter of biogas per day is enough to do cooking for one household, and also maybe have some lighting. I think this LPG costs per month is calculated on Vietnamese costs and prices. It's for the Vietnamese market, I think. Startup procedure, here we have as an example, and this grows of course depending if it's an industrial installation or whether it's a household, but there is a startup procedure where you need to, if you don't have access to substrate which is already producing biogas, then you need to start from somewhere, and one way of doing it is to use cow manure, for instance, where you mix 50% cow manure and 50% water, more or less, and then you have 20 to 30 days before the process in itself starts building up, and then you start gradually feeding in your organic waste till you reach the maximum what should be fed every day, and then you're up and running in anything from 40 to 60 days if you start from, this is from scratch. If you can get hold of substrate where it's already, where the process is already working, then of course it's much quicker than that. Global R&D, this is our objective is to become the most competent and the most knowledgeable biogas company in the world, and in order to achieve that, as I said before, we cooperate with you. That is hooked to this network. We have initial discussions with India, and Indian universities, both FOB Biogas has that, as well as the University of Borås. And the kind of research that is being done is we do on different substrates. you have seen a number of different areas where we're already operating, and there maybe it's of no interest, but there are also substrates that comes to us that where there is a big question mark whether this is suitable for biogas production or not. And then we can run this locally and see whether it works, and they get the assistance from the University of Borås, and that works very well. And the rubber industry and the sludge from rubber industry was a big question mark before we started doing that. I know textile is another area which we're currently doing, where we have done, where we received quite a lot of progress. Then, of course, we are constantly looking at speeding up our processes. So rapid digestion is another area where we do research. Dry digestion is a totally new technology for us. It's been around for quite some time. We have a lot of knowledge within this field, and our research partner, the University of Borås, have been doing a lot of things within that area for a long time. So that's well on its way, and we anticipate to have products in that area maybe in 2 to 3 years' time. Membrane bioreactors is mainly where you divide up the biogas process. Is not one big process. It's divided up in several different processes, and then there is this idea of also dividing the reactors or the digesters into different chambers, and that has been going on for quite some time. The reason is to speed up the process. We are also looking at a totally new system for biogas system for sludge and wastewater plants, which will dramatically change biogas production from that. We are also looking at new pre-treatment methods that's actually optimizing biogas production. And then constant work is to find new designs and so forth. And this is, as a customer to FMV Biogas, this is also what you get in the package. So you will constantly have latest technology, and because our reactors comes at a very low price or a very reasonable price, it is not difficult to scale up or change if that is needed. So we see this as a major benefit for our customers. Here is pictures from the lab. So we start things in the lab. We go through prototype phase where everything is being tested and so on. We do this worldwide, so we're not just testing in our labs or do field tests here at our facilities. It's also tested throughout the world, and for this we use then this network of universities. And then, of course, we travel ourselves a lot, and then that's we try to be as global and mobile as possible. And then why invest in our systems if we can compare them a little bit to traditional biogas systems? Our system is very durable and flexible, gives a reliable production compared to traditional system that quite often is has a low production due to poor quality, leakage, other things. Maybe has no production because of lack of competence. There is something that's gone wrong in the process at one stage, and no one knew what to do, and therefore it's just stopped. That we, with our support, that should not happen. We have the unique scalability where we can gradually expand the system based on your or the customer's production data. And it's in comparison to the traditional system is that where you where you need to go to a full implementation day one, normally for cost reason, and then into that, then you have a lot of uncertainties. Maybe it's much bigger investment also than ours, and there is a lot of guesswork. And then our systems is a reliable investment. It's short payback times. It doesn't at all involve the same amount of risk as traditional system that sometimes looks maybe as a seemingly low initial cost, but normally it's not. So those are the reasons to invest in our systems. A little bit about FOV Biogas, our legacy. FOV Biogas mother company is FOV Fabrics, and FOV Fabrics is a textile manufacturer, and we manufacture high-tech textile materials, and we have done this for 50 years. Our most known innovation so far is the fabric for airbags, for instance. That was developed by us now quite some time ago. But to mention some of our customers, we're leading a well-known global textile company. Is Gore-Tex, Prada, Louis Vuitton, Burberry, Puma, Formula One buys our materials, Autoliv, Volvo, BMW, Scania, Veolia, Statoil, City of London. That is just to mention a few of FOV Fabrics customers. We are a vertically integrated company, which means that we control and we monitor all aspects in the production, from the warping, weaving, dyeing, coating, and so forth, to a finished product. And then we have an extensive testing and quality control on everything that we do. So that is the background of FOV Biogas. That and together then with the University of Borås, that I also would like to mention, that is within the biogas production is one of the leading institutes and leading universities in Europe in that field. And Professor Mohammed Taherzadeh is a well-known figure in this area, and they are the ones that we are doing this together with. So that is the legacy and the background of FOV Biogas. If you want to know more about us, please visit our website, fovbiogas.com. There you can calculate your reactor size and also the amount of biogas that you can get and so forth. And you can download brochures. Shortly, I think this presentation will be on there as well. So, well, thank you very much for your attention. And now if I have some questions. Could someone please say something? I'm done with my presentation.
Hello, Mr. Frederick. Can you hear me?
Yes, I can hear you. Yes.
Thank you for the presentation, sir. We have a first question here.
Yeah.
The question says that for localized production of reactors, do FOV provide the welding machines, or are you looking for partners with this equipment and capacity?
We are initially looking for partners that can sell and distribute our systems. Eventually, once we have built up the Indian market to a reasonable size, we will be looking for manufacturing partners as well who can do the welding.
All right, sir. We have a next question here. It says, does it require to store the electricity generated through batteries? If so, what type of batteries? Does it require regular cleaning? What is the operational cost?
Well, this is sort of, in that sense, we are no different from any other biogas company. It depends on your needs. If you want to store the energy, then yes, you need battery, or electricity, sorry, then you need batteries. If that's the case, then our recommendation when it comes to accessory equipment that is needed for the special case is that we use local products for that, so we can have local support. So I wouldn't be able to recommend any special just for the Indian market in this case.
All right, thank you.
Was there a question on the genset as well?
No, sir. The question also asks that, does it require regular cleaning, and what is the operational cost?
If it needs cleaning, the gas needs cleaning. Yes, in order to a little bit depending on the substrate that is being used, because the different substrate generates different purity of methane. And but quite often to run generators or gensets, it needs to be a little bit purified, and that is depending on the situation. And this is also something that we provide, and it's not that costly. We try to find the most cost-effective way, but that will be included in the proposal that we put forward to the customer. This is also something that if we have done a demonstration installation, then we will know exactly how to handle this then for when you go into a more full implementation stage.
Okay, thank you, sir. We have the next question here. It says that, how will you check the vital parameters during the process?
Sorry, how?
How will we check the final parameters during the process?
Well, during the process, that is one area that we are currently developing, that we will have some sensor technologies that can measure different things during the production. Currently, we don't have that. So what is being asked is that if we're starting to see some problems, or we see the reduction in biogas production or whatever, then we are kind of ask them to take a sample of the digestate that they are getting out every day, and then that can be sent to our local partner who can analyze it. That's how it's been done to date. But long term, we see that we should be able to monitor some parameters: temperature, biogas production, maybe pH value, and maybe one or two more parameters that will tell us quite a bit about the state of the process.
All right, thank you, sir. We have one more question here. Do we require cleaning inside the fabric?
No. This is depending also from different situation and different substrate. I know that there are certain substrates that where you need cleaning, and where you can do this. It's sort of something that happens maybe every 4th year, every 6th year, and every 10th year or whatever. But that is also fairly easily done with our systems. It's quite easy to empty them, and it's quite easy then to get them started again. But they are in that respect, much easier than traditional systems.
Okay, thank you, sir. The next question we have here is, what is the differential in initial investment in FOV biogas system compared to the traditional system?
A little bit depending on what you mean by traditional system, but if we compare these traditional systems that we have here in Europe, normally European systems, we are anything from 1/5 to 1/10 of a European system. if we compare ourselves to more local systems like a brick digester, then we are on roughly the same. If we compare ourselves to composite, we are quite often a little bit cheaper. If we compare ourselves to lagoon, we are sometimes more expensive. But then you need to take into account that if you compare our systems to a brick digester, then there are several advantages with our system. It's not depending on the craftsmanship or anything of the workers that installs it. It will be of highest quality. There will be no leakage. And also, we can scale it. It's scalable. Of course, you can build several brick digesters, but that's not often the case. And we can build much bigger reactors. Brick digesters, the biggest I've seen is 300-400 cubic meter, I think, and we can build much bigger than that. And also, one advantage we have over that is that if brick digesters is dug down into the ground, and if you have any movements in the ground, then you have cracks and you have all kinds of problems with that. We have also seen that a lot of the brick digesters, they are not at all as durable as our systems. They actually break down before our system, so that's a big difference. Composites, difficult to transport, difficult to store. You cannot build big sizes of composite digesters. Once they are in place, and if you require only a 10 cubic meter, or because that's normally maybe 10-15 is the maximum that you can transport, then they are quite good. But for instance, in Indonesia, they have had a lot of problems with composite digesters. When it's buried in the ground, that they crack, and when they crack, they are totally useless. Lagoon digesters is sometimes, when they are done sloppy, they are cheaper. That's why I said cheaper. If they are done more correctly, they are more the same price as ours. But you have all kind of quality issues with them. You also have other problems of pressurizing the system, if I put it that way. So those are pretty much the pros and cons if we compare our system to these traditional ones. And with the European, I mean these who are made out of stainless steel and concrete, and the way we build our systems here in Europe, and comparing to them, then the cost effectiveness or the cost reduction is big in comparison.
Okay, thank you, sir.
Yeah.
We have the next question here.
Yeah.
It says that I understand that you are already represented in India. Is that right?
We are talking to 2 or 3 different partners, but that doesn't mean that we have enough. We are still looking for partners, and India is a very large market, and we don't sign any exclusive deals with anyone. If we do, then it's for certain application areas and maybe also geographical areas. Or having said that, we don't want to have 2 partners that are competing against each other. That's absolutely not our wish. But there is still room for more partners. And currently we are looking also for someone who could act maybe more as a distributor, which means that will be the importer that will actually buy things from us and then sell it on to customers. The ones that we're discussing now is selling ours and receiving a commission, and that is somewhat more difficult for us. So, and then we are long-term, not right now, but we need to start to plan for that. We're also looking for a manufacturing partner, and that is then the welding.
Okay, thank you, sir. We have the next question here. What kind of operational resources are typically required for running a 100 cubic meter system?
Operational resources almost none, I would say, apart from feeding it and taking care of the digestate, and that you do depending on how often you feed it per day. But let's assume you feed it, sometimes it's automatic, so it's a continuous thing, and then there is almost no one. Then you only have to have someone who handles the digestate, and maybe goes over and look and sort of takes a look at it every now and then just to see that there is nothing wrong. But then you can have other substrate where you need to have crushers and the mixing, and you have sort of a pre-treatment of the substrate. Then you need resources for that. But for 100 cubic meter, it's that is done manually very quickly and quite easily. So not a lot of manpower needed.
Okay, thank you, sir. The next question here is, does it have any operational challenges? For example, can rats destroy, or can it be punctured, or are there any problems of leakages?
We don't have any problems of leakages as such, but yes, it can be punctured. That can always happen. It cannot be a puncture cannot just happen. Someone needs to do something. If it's a sabotage, no one can protect oneself from sabotage. But then we have had occasions with rats and so forth. But we have never had a leakage because of rats. But we have had rats that have come in close to our installations, but we have managed to handle that. So we haven't had any experience or any problems with that. But what can happen is it hasn't happened anywhere where we have had a leakage. Actually, to be honest, what we have done is when we tested it in our field tests, and then if that is to happen, then there are repair kits, so it can be repaired.
Okay, thank you, sir. The next question would be, what are the preparatory earthworks that are required for installation?
There is not a lot. We want a fairly flat groundwork, maybe if possible with a very, very slight inclination. It's not required, but it is preferred if that's possible. Sometimes we need to dig down in order to get a good flows, because the digester needs to be lower than the mixing tank, for instance. In some cases that can also be good in order to protect it a little bit, but it's not required to do that. But that's quite often that we dig it down a little bit, and that's also to keep it in place and so forth. But other than that, very, very little that needs to be prepared.
Okay, thank you, sir. The next question here is, does the system include pumps, and are these within the reactor or external? Are they included in the system, or you provide, or that will be an external cost?
That will be an extra cost in that way, but it will be included in the proposal. But quite often the industries that where we install, they already have this type of equipment. They already have the pumps that are required, because they're already pumping their organic waste one way or the other. But sometimes it's necessary, however, to invest in extra pumps, crushers, mixers and stuff, but then that will be included in the offer, but it's not something that we produce and manufacture and as such, but that will be part of the system, and it will be included in the proposal, and it's something that can be chosen to be bought by us, bought from us or bought from someone else. What we're doing when it comes to these extra accessories is that we try as far as possible to have local products. The reason for that is to have access to local support. It's not only our belief that it's important that we provide local support for our systems, it's also important for us that if we buy something from someone else that they also have local support. We know how important that is.
All right. Thank you, sir. That was a really fruitful session. The remaining questions, Mr. Frederick will be answering it over mail. Now we'll be shifting over to the next speaker, Mr. Peter.
Okay. Thank you very much.
Thank you, Mr. Frederick.
Thank you.
Hello, Mr. Peter.
Good afternoon. Can you hear me?
Mr. Peter, we can hear you.
Very good. Can you see my screen also?
Yes, sir, we can see that.
Yes, good afternoon, ladies and gentlemen. My name is Peter Vasiliev, and I'm a director of a company called NeoZeo. And we focus on biogas upgrading, which is conversion of raw biogas, which just been described by Mr. Frederick. They sell units to produce raw biogas, and our company NeoZeo is focusing on conversion of raw biogas to produce biomethane. Okay. Next. I would like to remind you a simple fact that farms has been known for centuries to produce milk, vegetables, and different type of food. Well, now farms are getting well known to produce also electricity. But at the same time, all that organic waste which is produced at farms can be converted to vehicle fuel. And there is a huge need in such kind of vehicle fuel produced from organic waste. Countries like Sweden and Germany are the top at focusing on conversion of raw biogas to vehicle fuel at this moment. But it's a big challenge to convert small volume of raw biogas to vehicle fuel. And our company is at the top in the world focusing on converting raw biogas at farm and producing vehicle fuel from organic waste. And NeoZeo, as I said before, you could see on that slide, collecting raw biogas and pumping it inside of a container, a box, which remove different components, remove carbon dioxide, hydrogen sulfide, which is H2S, and water. Then that upgraded and purified biogas, which is called biomethane, is compressed to 250 bar. The biomethane at 250 bar can be fueled to different types of vehicles, like cars, buses, and trucks. and tractors. And our focus is on scale from 50 to 200 cubic meter per hour. That means that normal farm in Sweden and Germany can produce exactly that amount of raw gas. And our company is focusing to convert that particular flow of raw gas to vehicle fuel. Next slide. Here I would like to compare what does it mean to produce electricity and what does it mean to produce vehicle fuel. You can see at the top, I'm trying to convert 2 cubic meter of raw gas, which is produced by a farmer, for example, and then we use model produced by offered by NeoZero. We can produce 1.2 cubic meter of biomethane. That 1.2 cubic meter of biomethane is equivalent to 1.32 liters of gasoline. Well, I mean, I'm not completely aware of the price of gasoline in India, but you can easily calculate what would be the revenue for a farmer or for a producer of raw gas to sell or to utilize that 1.32 liters of gasoline. Well, the second scenario is where you convert 2 cubic meter of raw gas to electricity. Then maximum usually you can produce 4.2 kilowatt of electrical energy using 2 cubic meter of raw biogas. Well, again, now you can easily compare, knowing prices of electricity and gasoline in India, you can easily compare these two values, and I believe you will see a big advantage to produce vehicle fuel from raw gas. Our model, which is biogas upgrading model, consists of several parts. And one part, which is the heart of the model, is called pressure swing adsorption unit. On left side, you can see two columns which are filled with adsorbent, which is in the middle of the slide. And that adsorbent is the know-how and patented technology of NeoZero. We are, in our company NeoZero, we are focusing on research and development of different type of adsorbent with specific properties for separation of carbon dioxide and methane. And we developed a volume efficient adsorbent which can efficiently separate carbon dioxide from methane. The adsorbent is structured and placed inside of the columns. That unit then placed inside of container and connected to other units, for example, pressure compressors to compress raw gas, filters, coolers, and units to separate water and hydrogen sulfide. All these components are inside of a container, which you can see on the right side. Of course, the container is specifically designed for particular flow rate of raw gas and particular composition of raw gas. Composition means percentage of methane and carbon dioxide in a mixture. Here I just would like to describe a little bit more about the core technology. And as I said, it's called pressure swing adsorption technology, and abbreviation is PSA technology. We pressurize raw gas, which is a mixture of, mainly mixture of carbon dioxide and methane, and push it through one of the two columns. then CO2 gradually would absorb inside of a column and gradually would fill it up with carbon dioxide, because adsorbent, which is placed inside of a column, has a particular property to capture CO2. And at the same time, methane is not captured, but methane is going through the column and collected as a product inside of a third vessel. Well, when the column is full with carbon dioxide, and we know about that based on our optimized conditions, and we know how long time would it take to fill up a particular column filled with adsorbent, we close the column, and then we push the same gas through the second column. Means the process is continuous. While the gas is pushed through the second column, we regenerate the first column. And regeneration is using vacuum. More or less, we evacuate the column and remove the carbon dioxide from the adsorbent. Means the adsorbent can be used many times, and typical lifetime for adsorbent is 4 years. But the lifetime for the total module is over 10-15 years. Shortly on that slide, you can see advantages for producers of raw gas and for potential distributor of biomethane. Typically, these two companies or persons are different in Germany and Sweden. It may be one person who is a producer and distributor, but let's look through the lines. I mean, for producer of raw gas, is that producer can get extra profit compared to production of electricity, and that one I have shown before on my previous slide. They can use biomethane, which is a product after cleaning of raw gas. They can use biomethane for own use, means they can fuel their own cars, they can use it to fuel local trucks, for example, for distribution of milk, distribution of vegetables, distribution of other products, local products. Also, they would get a better environmental advantage. Again, it can be a local support from a government. For distributor, again, it can be the same as a producer, means it can be advantage for the main supplier of raw gas. Additional advantages are reduction of transportation cost, means you don't need to get and transport vehicle fuels to your vehicles which you are using locally. Means if your city is remoted or even can be separated from the main big harbors where the fuels come from, you can easily establish your local fuel production and be independent from global suppliers. And second is more biomethane to customer. Again, it comes to a well-developed network of fuels, means more customers would like to come and fuel their cars. You can easily increase the production of biomethane locally. You are not dependent on global and centralized suppliers. You can be easily decentralized and supply a particular number of vehicles. And of course, third one, which is similar to the previous discussion, is environmental advantage. Again, you will definitely get a better recognition in the world and locally to be a supplier of environmental fuels. And hopefully get benefits from local government. Here I just show a process diagram. Again, our model is kind of consists of different parts, and the model should be built based on requirements from a producer of raw gas. Before we proceed, we need to know details of your production and composition of your raw gas, and what's your business model, how to distribute the upgraded biogas, biomethane. I mean, our company NeoZeo can help you at each stage, but here I would like to show some technical specifications, what you should consider before discussing it with us. And then, in principle, what you need, of course, first is a raw biogas production facility. You need to have a raw biogas. That raw biogas need to be dried and cleaned to remove hydrogen sulfate. Again, some raw biogas production facilities used to have dryers and H2S filters, but some of them does not. Again, if you have already production of raw gas, then please investigate if you have dryers or H2S filters. If you don't, definitely NeoZeo can supply these items. Then second, which is optional, we must have a low pressure compressor which would increase the pressure for raw gas. And then we need to have cooler, and then the cooler would cool the gas, and the cooler has possibility to be work on air or water. Water is preferable, but again, it depends on particular local situation. If you don't have water supply enough to provide cooling system, then we need to investigate the possibility to cool the gas using air. Then the model would have a receiver to reduce the fluctuation of pressure from low pressure compressor, and then the raw gas will be supplied into the upgrading unit, which I call the heart of the model, upgrading model. Then it's of course a set of different valves, and then a vacuum pump which would regenerate the columns, and then it will be a unit to handle a small traces of methane which would remain after cleaning the gas. And as a product, it will be placed analyzer which would analyze the product in order to reconfirm the quality of received biomethane. And then the product would be received in a receiver, and then it will be compressed using high pressure compressor. And high pressure compressor, again, it's designed based on particular flow rate and particular requirement to the end product, because end product could have 200 bar, 250 bar, and 300 bars. And then the final part of the diagram is the storage of a product, or storage of biomethane. And there are different options how you can store it. If you would like to store it just for local use next to the upgrading model, then you can utilize steel cylinders. If you would like to transport it, and then it depends on how big is the distance, then you can utilize second generation composite cylinders made of carbon fiber and aluminum, or you can use third generation pure composite cylinders, which is much lighter and can be more efficient in terms of delivering the biomethane to the end customer. And I would like just to say one more time, many parameters must be considered before we can make a particular offer. And you can see the model consists of many different parts. Yeah, a little bit more about the team. I mean, myself, which is the photograph on the right, the top right photograph, as I'm a CEO of NeoZero. We have also office in Latvia. Our board and research and development leaders are Leonard Bikström at Stockholm University and Nicholas Hedin at Stockholm University. Also, we have Thomas Octadius, who is focusing on business development, and successfully worked in 10 different companies. We have a research groups in 2 universities, one at Stockholm University, where we're continuously focusing on developing new and improved adsorbents for separation of carbon dioxide and methane. And you can see Zoltan Basic senior researcher, Ocean Chain researcher, and Pangiotis Krokidas researcher focusing on modeling. More or less, we are focusing not only experimental, real experiments, but also on optimization and modeling of a real process using computers and programs GPROM. When researchers at Riga Technical University focusing on more in research and development of the model itself, testing different parameters and testing new adsorbents for separation of carbon dioxide and methane. And these researchers are Yanis Rugilis, Christina Rugili, and Yanis Neilands. Also, we have 2 engineers focusing on engineering of our units for particular requirements from our customers. And whenever you have a particular request, our engineers would be happy to design a specific case for your needs. And of course, we have a strong network in Sweden in the field of renewable energy and a deep knowledge of porous materials for different applications outside of biogas upgrading. Our company is supported with different agencies like Vinnova Energy Agency, CEDAR and LEA, European Union organizations like ERAF and LifePlus, and we have a cooperation with different companies. For example, Agricultural University in Sweden and at Uppsala, Riga Technical University, Stockholm University, Excellence Center on Porous Material. We are part of a big project which is called Biogas Expos, together with Vafab Milieu, a big producer of raw gas, and Institute, Agricultural Institute in Sweden. And I would like to say thank you for listening, and welcome to ask me your questions.
Thank you, Mr. Peter, for the informative presentation. Now I request all the audience to type their questions in the chat box in the right side. We have a question, Mr. Peter. The question says, what kind of partners would you seek in India?
You may realize from my presentation that the product itself is not simple. Means it's not just only one compressor. It's a set of different units which should be combined in order to deliver a final model. Means we would prefer to have a partner with a good engineering and customer based in India, with a good contact with raw biogas producers. The customer who can handle initially some simple questions from potential customer, and at the same time a customer who can be easily taught in order to in future develop projects for a particular case.
Okay, thank you, Mr. Peter. The next question is, are you interested in contacts with research institutes in India?
Definitely we are, but we need to discuss what type of cooperation is possible in India. We have not been in touch with Indian research groups yet. Means we are open for discussion, and universities are welcome to contact us. But it should be a particular suggestion how they would like to cooperate.
Okay, thank you, Mr. Peter. The next question here is, what is the minimum biogas required for installation of the system?
Right. The minimum, in order to make it a good business, our assumption is that it should be 100 to 120 cubic meter per hour, the flow rate of raw gas. 100 to 120 cubic meter per hour. Again, if you are not producer of raw gas yet, then it must be evaluated before, more or less. You need to use tables. For example, there are tables available online to calculate how much raw gas you can produce per year using a particular substrate. And then you can divide it by a total number of days minus 10%, just in case if there is a failure of raw biogas production. And based on that number, you can calculate what is your flow rate of raw gas per hour. And our units are focused, mostly will be will create a high revenue for you if you would have from 100 to 120 cubic meter per hour. I mean, if you have more, it's even better. But that 100 to 120 is a good flow.
Thank you, Mr. Peter. The next question here is, how is it cheaper from Indian technology available of PSA type and cost comparison? And what is the ROI?
Cost-wise, to available technologies on the Indian market, yeah, that's a good. But I would say we currently focusing with our company. We haven't sold any units in India. Means our partner in India should help us to reduce the current costs, which we have in Sweden. Then, in a way, the cost will be reduced, and I will not compare the cost at this moment, because costs are always depends on the labor and the supplier and engineering team. Also, the cost would be lower because of local requirements, where in Europe, for example, it's a strong suggestion to utilize equipment which are APEX approved, which increase price for particular product at least 2 times. And by via cooperation with a partner, we need to identify that particular requirements and local market, and then find cheaper versions of a product available in Europe. What was your second question? I have not understood completely. Please repeat.
The second question was, what is the cost comparison and return on investment?
Okay, probably when I answered to both questions, yes, thank you.
The next question here is, what is the minimum quality parameters required of the biogas, and what is the delivery time of smallest capacity available?
The quality, I mean, the best if methane amount in 1 cubic of raw gas should be at least 60%. That's the best. But of course, if it's 59, it's also fine. But it should not be below 50. More or less, amount of methane should be around 60%, and then the rest should be CO2. If there is a nitrogen present, then it's a drawback for our technology. Nitrogen is much more complicated to separate. More or less, we don't focus on landfill raw gas, but we focus on raw gas produced from organic waste.
The second question was, what is the delivery time for smallest capacity available?
You mean like delivery time for our product to end customer, right?
Yes, sir.
Well, typically time in Europe it would be 3 months. Again, we have not sold it in India. I would say it would take longer time. My estimation would be maybe 5 months.
Okay, thank you, Mr. Peter. The next question is, can the porous material take care of also the other impurities in the raw gas, or would those destroy the porous material?
Any kind of impurities would be I mean, definitely must be removed using different pre-treatment units. More or less, for example, water must be removed. H2S, hydrogen sulfide, must be removed. If there is any other additional elements, it can be siloxanes, it must be removed too. Again, the quality of raw biogas should be evaluated before we would make a design for the raw biogas upgrading model. And our company can provide each unit. It's just a matter of that we must know what are these components. And of course, if you don't have local analyzers, then NeoZero can help to analyze the gas too.
Okay, thank you, sir. The next question is there any refuse coming out of the system? If yes, how to handle it?
Could you repeat again, please?
Is there any refuse coming from the system? If yes, how to handle it?
There is a small amount of methane slip, which is about probably 1.5%, and usually it's flared. More or less, we push it through a burner, catalytic burner, which would convert it to carbon dioxide.
All right, Mr. Peter. The next question here is, will the pre-filtration step increase the cost significantly of the system?
Well, that's a good question. I mean, it depends on type of contaminations. If H2S amount is very big, it would increase, but not drastically. It would increase operational costs, not the investment costs, because operational costs would relate to material which will be used for removal of H2S, and there are different type of material used to separate H2S from raw gas. Material can be selected based on the requirements, local requirements, and particular situation, because the cost for material is different, but also the how you work with different materials is different also. It must be investigated for a particular case. I cannot answer in general, unfortunately.
Thank you, Mr. Peter. The next question we have is, if this system can be used in scientific landfill facility where there is a potential of gas emission where percentage of methane is high.
The most important is if there is a big amount of nitrogen in a raw gas. If there is a nitrogen in raw gas, which is typical for landfills, then our system would not provide a very high purity methane. More or less, typically it will be a mixture of methane and nitrogen. And again, any kind of enriched methane can be used as a vehicle fuel. It depends on local requirements. Local requirements, for example, in Sweden, biomethane corresponds to quality of biomethane of where methane amount is at least 97%. And of course we are targeting that value. But if in India there is no requirement to have 97%, for example, if there is a possibility to utilize 90% methane and where 10% is nitrogen, but then you can use it as a vehicle fuel. It's just a matter of that the government would force you to remove the nitrogen because the engine can utilize 90% methane and can burn it to run the vehicle fuel. It's related to more, if you have your own fleet of vehicles, you can use it as a vehicle fuel. And then again, each case must be discussed and investigated in details.
Thank you, Mr. Peter. The last question we have here is, does a system allow for collection of CO2 to be used in another system?
Unfortunately, I didn't understand the question. Can you repeat, please?
Does the solution allow for collection of CO2 to be used in another system?
But do you mean like CO2 for food industry, or because CO2, definitely you cannot use CO2 from our system for food industry, because food industry require very high purity carbon dioxide. And the CO2 which comes out from our system would have a very small amount of methane and probably other type of gases. But it can be used, for example, for greenhouse production, more or less, where there is a requirement to higher concentration of CO2, then definitely you can push that CO2 into the greenhouses or just to a plant area to increase CO2 concentration. I hope I answered to that question. Yeah.
Yes, Mr. Peter, thank you. We have one more question here. Normally, if you have 90% methane in the gas and 10% nitrogen, would it be useful as a vehicle fuel?
I believe so. I believe so. It's just a matter of how to set up the electronic block, which is typically installed on vehicles, to make a correct proportion of that particular methane and oxygen. I would say we are not experts in that particular area, but definitely it can be done.
Okay, thank you, Mr. Peter. We have a final question here. Would the system support such utilization of CO2?
Could you repeat again?
Would the system support utilization of CO2?
That's a difficult question. It depends on what do you mean by utilization of CO2.
meaning to use it in greenhouse gases.
Yes.
To use that in greenhouses.
What is unique in production of biogas, in production of raw biogas, is that you can capture methane. More or less, first you collect organic waste, and then from organic waste you produce raw biogas, which is a mixture of CO2 and methane. And then you recover methane in different terms. You can convert methane to electricity, but again, when you convert methane to electricity, you still produce CO2. Or you can convert it to vehicle fuel. Again, after burning it in engine of vehicle, you produce CO2. Well, when the purpose here is not to recover CO2, but the purpose of all the value chain is to recover methane. Because if you would release the organic waste just on a field or in landfill, then the methane still formed, and then methane is released to atmosphere. And then methane is 22 times more harmful than carbon dioxide. Then the idea here is not to capture CO2, but to capture methane. And then if you would read the different life cycle analysis, and then the total value is negative. More or less, when you look at the value chain of vehicle fuel production from raw gas, then the total contribution is negative. While, for example, compared to production of bioethanol and biodiesel, it's not negative because you need to grow crops, you need to employ a lot of energy for it. Here you don't grow crops, you just utilize waste, which you still need to throw away, and then that waste would contribute to production of methane. Thank you.
Michael, hope we are done with all the questions, Michael.
Yes, sir. That was the final question.
Yeah. Okay. Friends, let me formally thank the speakers, Mr. Fedrilla Johansson from FOU Biogas and Dr. Peter Vasiliev from NeoZio for their very fruitful presentations related to their innovative technologies. Let me also thank all the participants for their interactions. You can also ask more and more questions. You can directly feed in their questions, your questions through the web portal. All these presentations will be, please note that the entire session is recorded. The presentation, the recorded version will be uploaded in our website shortly. We have a specific website related to this called the Innovation Accelerator platform. You can go to innovationaccelerator.com. This is the website through which we are trying to facilitate the interaction between the Swedish technology suppliers and the Indian counterparts. So my request is for the Indian participants to register yourself in the Innovation Accelerator website and also periodically participate in all the discussions. I would also request you to share your feedback about these two companies with us. This will help us in terms of understanding your requirements better and accordingly keep the Swedish companies informed. We are also planning for a similar similar webinar tomorrow. We have two presentations. One is from ED Biogas and second is from YesSolar. So I would request you to join for the webinar tomorrow as well. These are kind of web-based interactions we are trying to facilitate between the Swedish companies and the Indian companies. And we are also planning to bring as a mission of all these innovative Swedish companies to India during the month of April, both in Mumbai as well as in Chennai. In Chennai, they will be available on 27th and 29th, and in Mumbai, they will be available on 23rd and 25th. So we are planning for a kind of workshop and also a very formal interaction between these Swedish companies and Indian companies. So I would request you all to make yourself available at your convenient place. I mean, either Mumbai or Chennai, and then interact with these Swedish companies, explore the possibility of cooperation and business development. I wish all the very best for all the participants, and also thank the speakers once again. Thank Mr. Ludwig and his team, and also the Business Sweden, Mr. Sandeep Sabla. Thank you all. With this, we formally close this session. Thank you. Thank you very much.
The organizer has ended the session, and this call will be disconnected.